Part 284C3M1B7C8E13C9C6D3P38D19D7b53 Line 22f1fa19C3M1B7C8E13C9C6D3P38D19D7b53 NMR sensitivity quantum dipolar PISEMA 5G Wow Seti. There's the alien radio signal. And it was worked on May the 8th, and today's the 31st of May, 2013. So this is NMR Methodology, Sensitivity Enhancement PDF Experiments, Research Keywords for UFO Spaceship Communications Device in the Well Data. So SAM14 is a pulse sequence to PISEMA. Data continues from this video, NMR Sensitivity Quantum Dipolar PISEMA. And a quote from a blog. Our latest development in NMR methodology, sensitivity enhancement in solid-state MR experiments. We present a new method for enhancing the sensitivity in solid-state NMR experiments for a gain and signal-to-noise ratio of up to 40%. The sensitivity enhancement is different from the corresponding solution NMR sensitivity enhancement schemes and is achieved by combining single and multiple quantum dipolar coherences. While this new approach is demonstrated for the polarization inversion spin exchange at magic angle PISEMA experiment, it can be generalized to the other separated local field experiments for solid-state NMR spectroscopy. This method will have a direct impact on solid-state NMR spectroscopy of liquid crystals as well as membrane proteins aligned in lipid membranes. And there's a graph there showing the end chemical shift in the SE PISEMA and the PISEMA for dipolar couplings. Top is a comparison of a two-dimensional spectra of N-acetyleucine, up top there, from the left conventional PISEMA and right SE PISEMA experiments. And then bottom is a comparison of one-dimensional slices from the two-dimensional experiments taken at 187 ppm, showing an increase in the signal to noise. So this is from sensitivity enhancement in solid-state MR experiments via single and multiple quantum dipolar coherence, 2009. Veglia Research Group. One sample approach for protein so this is a quote from a blog. One sample approach for protein complexes. We present a procedure for isolating subspectra corresponding to individual protein or peptide components in a ternary mixture or complex. Each of the three component species is labeled differently. Species A uniformly with 15N species, B uniformly with 15N and 13C. And species C uniformly with 15N but selectively with 13C or 13 alpha. By using the dual carbon label selective HSQC, DCLS, HSQC pulse sequence and exploiting differences in 1J, 15N to 13C coupling patterns to filter selected 15N resonances from detection during a constant time period. Subspectrum from each species can be generated from 3 spectra acquired from a single sample. Many important biological pathways involve dynamic interactions among members of multi-component protein assemblies, and this approach offers a powerful way to monitor such processes. And there's a graph there showing the DCLS HSQC pulse sequence. Representative spectra obtained at 37 degrees on variant VNMRS 800 MHz spectrometer equipped with a cryogenic probe. Okay. Then it's full Ternary mixture consisting, I'm not going to read all these numbers because it's unibictine, forget it. You guys can read it. Just go to the blog and you can see it there. Masterson, LR, Tonelli, some simultaneous detection and deconvolusion of congested NMR spectra containing 3 isotopically labeled species from 2008. Asymmetric methyl group labeling approach. We present an asymmetric isotopic labeling strategy for probing unambiguously membrane protein binding interfaces in homooligomers. This technique is highly sensitive, rapid, and requires only 13C methyl edited nuclear Overhauser effect spectroscopy NOESY spectrum. As a proof of principle, we apply this technique to the pentameric membrane protein phospholamban, defining the leucine isoleucine zipper interface. Well, you guys know how to make the most difficult words to read. Between its monomers with atomistic resolution. I got it out. Okay, there's the membrane there on the left. It looks like a DNA thing. And then on the right, dots, blue and red dots. Isotopic labeling scheme is shown on the pinwheel model of phospholamban. The red monomer of PLN is labeled with all those numbers. The blue monomer is labeled with all those numbers and letters. Owing to the precursor chosen, only one of the methyl groups in the val and loose sample is 13CH3. Constant time HSQC experiment on the 1-1 mixed sample showing more letters and numbers, and you guys can read those on your own. Asymmetric methyl group labeling as a probe of membrane protein homoglobiners by NMR spectroscopy. 2008. www.chem or chem.umn.edu, and you can check out the blog link there, and then you can read all the notes yourself. So the keyword is SAMP14 is a pulse sequence to PISEMA. We're still working on that in the next video. Thank you for watching.